the practical, right? In the first one, you are given a CSV file called uniform.csv. So what I have asked you in this exercise to calculate the LP distances between all pairs of the first 10 data points, right? So this data set consists of many data points or rows or instances, but for the sake of simplicity, which you will need to work on only the first 10 of them, right? Not all of them, because it's just really big matrix that you have to calculate. So what do I mean by compute all the LP distances between them? You need to come up with basically a matrix, right? And each entry is a LP distance between one particular pair of the first 10 data points. So you need to compute maybe a matrix of 10 by 10, all right? So each entry represents the distance, LP distance between a particular pair. In the second part of this exercise, you need to compute what is called the contrast measure on the data sets. So once again, right, we have to go back to the lecture slide, or you have to go back to the lecture slides and understand what the contrast really means. It just basically means a relative spread out of a set of points, right? I think there is, a page on the text in the textbook that describes this in more detail, right? So the formula is given in the lecture slide: the max minus the mean divided by the average, right? So that gives you an idea. And the max and the means, they are the maximum and the minimum distances from each point of the set to the origin, right? That's the thing. Now the second challenge is that you have to repeat the exercise after sampling the first R dimensions, right, where R varies from 1 to the full dimensionality of the data. So this is another exercise, well, similar to the previous exercise in the previous break. What I would like you to do is to make sure you get some stable result, right, for those of you who are programming students. Okay, so that is the first exercise. So you have to first of all load the data, right? So the steps are, first of all, you have to load the data. That should be easy by now. You have to select the first 10 rows, obviously, for the first part. Then you have to calculate the distance matrix, right? Finally, you have to find the contrast measure. Okay, so as I said before, for the contrast bit, if you are a non-programming student, you can stick to 10 rows because that might be more tractable. But if you are a programming student, it doesn't matter. You can select all rows, right? Let's move on now to the second exercise called nominal similarity. So I hope that you have a copy of that one. So here it is. I have refined this slightly. So in Practical 2, you have play around with this data set. It consists of 10,000 samples, right, of the KDD CAP network intrusion detection data set. So the first thing that you have to do is to remove numeric attributes and only keep the categorical or nominal attributes. That's the first thing you have to do. The only problem is that as soon as you remove numeric attributes, many rows becomes very similar. So they are actually duplicates. Becomes duplicate. They were not before because of the presence of numeric attributes, but now because we have removed the numeric attributes, so they become identical, right? So the second step is to make the exercise more meaningful. Then you need to remove all duplicate rows. So you should be able to do that by now, following the exercise in Practical 2. To make it simple, I ask you to just randomly pick a data point or a row, right? And then what you do next is to compute its overlap similarity score to other data points or rows using the inverse occurrence frequency measure and plot these similarity scores. Okay, so for exactly the same in the lecture slide. And finally, you find its nearest neighbor, which is the one that has the highest similarity score, right, to the row. Now, as you can see from these two exercises, the goal of these two exercises is to make sense of the concept that you learned in the lectures, in the workshop. In the lecture or workshop, we were solving a very, very simple and small size problem where we
All right,
can do all the
good evening,
calculations
everybody.
by hand.
Are you
However,
online? Can you hear me?
in reality,
Yeah.
we are likely
All right,
to
thank you.
have more instances, more
Right, we give
attributes,
a few
and
more minutes for people to
work
arrive,
using
but
hand,
yeah,
working by hand is not
while we wait for
practical
people to
anymore.
arrive,
So
let me just
these exercises
go around and ask if you have
give
any
you an
questions so
opportunity
far
to
about the
deal
unit,
with
about the
larger
products, about
dimensions,
the
larger number of
lecture
instances or rows.
contents.
All right, so what I'm doing
Is there
now
any
is I'm
questions?
going
Because
to explain
what I
a little
observe
bit
this year is that class is
for
very
those
quiet.
non-programming students.
Not many
Right?
questions
So
on
see what
discussion
they
board that
can
I
do.
can see. People seem to
And then
be
I will
happy.
talk about Python programming for the programming student.
All right. Is there any question about the last workshop?
So first of all, for the non-programming students,
we sort of solved
right,
most of the questions, I suppose, but there are a few questions left. Has anyone attempted the rest of the questions?
Program, maybe if you're using Linux or Mac, maybe you have different programs, but I mean,
yes, no.
As far as the functionalities are concerned, similar to Excel, so I refer to Excel for the sake of
okay. So I hope that you
right?
you're all fine with
this,
the tutorial questions, right?
It doesn't have the features that we are actually after.
Yeah.
So you can use a little bit, but not all of it.
Okay.
So let's have a look at the first exercise. So in the first exercise,
yeah, if you have any
set,
if you have any concern, you can ask me now or
CSV that you have to load,
later.
Right? So hopefully that you can.
But I suppose that
So
last
one important thing is that
last week we were working on the second last question, right? Was question 8 and was about the edit distance, and we only solved half of it. And the other half, I thought that yeah, I would leave as an exercise for you to do outside. Has anyone been able to work out the edit distance or the long common subsequence distance between them? Similarity, sorry.
First 10 rows, randomly pick 10 rows. Right. So if you recall from the previous sprite, then
okay, no problem. If you have done that questions and if you want to check the answer, you can send me a private message, right? No problem at all. All right. So if there's no question before we start the workshop today,
you can do randomize and
yeah, that sounds about right. Yeah, it is about right.
10 rows randomly from this. So what you can do
let me just yeah, 2 and 8 is about right. If you got 2 and 8 is about right. I hope that you have I suppose gain knowledge and skills with data preparation, right? I am finalizing the assignment today. I hope that I can make the assignment available after the workshop, midnight probably. So it is important that you understand data preparation, right? So what I would like to do now is just to conduct an activity that reinforces your understanding of data preparation through the quiz. So if you can open Blackboard, I think there's a quiz called data preparation quiz, but if you don't have that, that's also fine. We can discuss here. I'm just sharing
what I have here is, when you
Google
first load
Chrome
the file
tab,
into
which
Excel,
is
right,
data mining quiz, Google Form.
and
Yeah,
select
let's go one by one. See.
Sample like what I'm doing here.
All right.
But anyway,
when you open now the first one, the first question I would like to ask you here is you have resampling the data set, you have creating new features or attributes, imputing missing data, performing principal component analysis. What do you think is about data cleaning? A, B, C, D, or none of these at all? Okay, so what about I am just using a poll, multiple choice. So whatever question 1, whatever A and B, A choice, C, A choice, D, A choice, E. Okay. here we're talking about data cleaning, right? Cleaning. Cleaning is part of the data preparation. So, all right, I still have another 18 people haven't responded yet. So give another a minute or so for people to I guess understand all these answers and select the one that they think is the best. All right, another 14. All right, so 14 people haven't made decision yet. All right, anyways, I close the poll now. I think the majority of you selected the answer correctly. That is option C, right? Imputing missing data. So resampling or creating new features or performing component principal component analysis is not as good as imputing missing data because you know you might have missing data in the missing entries in the data. Right? Second question. Feature extraction or attribute. We normally call it feature extraction. We don't call it attribute extraction. But yeah, have a go. Let me just run another poll. Question 2. A, B, C, D, E. Okay. All right, we still have another 20 people. All right, I end the poll there. There's another 15 people who haven't made decision yet. All right. Now, for these questions, I have 25 students, right, which is the majority, have selected option C, which unfortunately is not the correct answer. People who selected A is the correct answer. C is not feature extraction, but actually called attribute or feature selection, right? Because it is about choosing a number of attributes from the original attribute set, whereas feature extraction is a process that works on the original raw data, and then you create new vectors of values that describe the problem really well, right? So that means that the majority have problem with distinguishing between feature extractions and feature selection, right? You can read from the slides again to reinforce your understanding. Right, the next one is, let's do the quick one. Question 3. If you need to convert numeric data to nominal data, which one would you choose among these methods? We have Weber transform. We have, let me just get question number 3. This should be an easy one. A, B, C, D, E. Okay. So have a go. Should not take you more than 1 minute. All right. All right, I stop the poll there. There's still 20 people who. All right, so the majority of the class select discretization, which is correct. Some people still selected binarization, which is the opposite, right? And standardization is the method that only applicable to numeric data, but it's only produce numeric data, right? So it's not going to change the type of the attribute. All right, so for those of you who select, answer which is not B, right, then you have to read the lecture slides or the textbook again. Okay, another quick one, very basic one, question number 4. Which method converts nominal data to numeric data? So once again, multiple choice question is 4. Yeah, okay. B, C, D, E. All right, and for this question, the majority of the class selected the right answer. Somehow, some people still selected A, C, or E, right? Binarization is the right answer because it converts nominal data to numeric data. So depending on, you have like, I think in the lecture slides, right, we have the option, we have the example of I'm not sure, red, blue, green, or high, low, medium, right? And we convert to 0, 1, sorry, a different number of bits, right? 0, 1, depending on how many nominal values are there, right? So that's another question. Let me see if there is another interesting question. All right, okay, this is better. This one, this question number 5 here is easy, but what I want you to think, right? This question number 6. Remember, right? We have the method called discretization, which you have stated above. Now I'm asking a question, right? In the tutorial, we have seen an example where if we perform equi-width, discretization, and equi-depth, they produce different intervals, right? The question here is, when do you actually see the same intervals produced by both of them? So I would like you to think for a little bit, and whoever can find the answer. Yeah. You can speak. You can, yeah, or chat, depending on. Yeah. Okay. So, yeah. When they okay, yeah, so normal distribution is not the correct answer. Yeah, so Ruby and Joby, your answers are sort of correct. Yeah, but Joby, probably your answer is the best when you have the uniform distribution, right? So when you have the uniform distribution, it doesn't matter equi-width or equi-depth, they produce the same intervals. I'm not sure if yeah, so there's someone say how, right? So I would like you to first of all, right, you have to understand what the uniform distribution is first, right? Uniform distribution is the kind of distribution wherein you how can I say it? You have the same probability or probability density, to be exact, right? For any values, it doesn't matter where is it. For example, probability of x equal to 1 is the same as probability of x equal to 10, something like this, right? Suppose that x is from 1 to 10, and it's the same in between. So in the tutorial, we have a what I call histogram. with the histogram, then we can see that the number of the height of the bars, right, represent the number of counts in each intervals or each bins. And we can see in the tutorial question that they are not the same, some like 10, 60, 30, and 100, right? But when you have uniform distribution, they are the same. For example, 30, 30, 30, 30, 30, right? Everywhere is the same. So if you form equi-width and equi-depth, they will produce the same intervals, okay? If you want to understand how, then you can sit down and try to work it out, right? I don't have time to explain in detail, but I just give you some hints there. What is the next one? All right. Question number 8. All right, this is the skill that I expect you to gain after you play around with normalization or standardization, all right? So what I would like you to do is to, we didn't cover question 7. No, we didn't cover question 7. I just jumped question 8. All right, so I'm not sure if this question makes sense to you, but let me just make it easy for you by going back. Okay, so good. All right, I will run a poll quickly, right? Give me 1 second. But what I would like to explain first, right, to people is what I mean by this is that this is a typical sort of what you can see with the Weka Explorer interface. And then if you click on attribute, for example, in this case, I click on attribute 7, it will give me, for example, minimum value, maximum value, mean and standard deviation, right? So these are the 4 values that you can read out straight away from Weka, right? Now, for example, the question is, this attribute has been normalized or standardized, right? But you don't know which method is this, right? So the question is, by looking at the 4 values here, minimum, maximum, mean, and standard deviation, right? Which one do you think the most important piece of information that will allow you to conclude whether normalization or standardization has been applied to this attribute? All right, I thought that's what I mean. So think about that and tell me what's your choice. Give me a moment. I run here. Question 8. This is B, C, D, E. Okay. All right, so we have lots of different choices. I end the poll here, right? So some of you select what goes standard deviation. Some of you say like max value, some of you say minimum value and mean value, right? So these are the choices. I think most of people have selected standard deviation or mean value, right? I think few of you actually choose maximum value. Yeah. So this question is actually very open. It doesn't matter which one you choose, right? They can, depending on the distribution of the data and depending on the, for example, some of you selected standard deviation, right? Can you explain why you selected standard deviation? Any? Oh yeah, but what I mean here is what you call it? If you have to select only one, right, and you try to make sense of whether normalization or standard deviation, right, that has been applied. I mean, it will depend on people. Some people might find the maximum value, for example, but maximum value is really hard. It might not work all the time. It might fail sometimes, depending on the distribution, right? Standard deviation, yeah. If standard deviation is equal to 1, then it's been normalized. How can I say it? Kevin. So if you have seen standard deviation 1, right, it's been normalized. But is it possible for normalization to have standard deviation equal to 1 as well? That's my question. Okay. I'm very surprised that none or maybe very few people actually choose the minimum value. I don't understand why people do not choose minimum value, because remember with standardization, right? Minimum value will always give you a negative number. For sure, that's very different from normalization. So that's another important piece of information you can rely on, right? So regardless of whether some distribution might look a little bit, not usual, but with standardization, you always have half of the population, half of the data on the negative and half of the data on the positive, right? So the mean could be also be used well, but the minimum, if you see something negative, you don't have to be worried. So definitely, this is standardization. Whereas in the case of normalization, the minimum value should be 0, right? As by definition. But anyway, this question is meant to be open questions. I want to highlight the fact that there are few that you can apply. Anyway, that's really enough, right? I just want to stop the quiz here because we have lots of things to cover. It's just because data preparation is very important, and it is part of Olivia. If I have this in the test, probably I will pose it as a different questions, and depending on your arguments, right? Okay, so let's move on to the main topic today is association pattern mining. This is a very, very important topic, and it is part of the test as well. So it is important that we fully understand this, right? First of all, I assume that you have watched the video, right, that I explained this lecture. So in this lecture, we look at first of all, right, some fundamental concepts of association pattern mining. And then the second part is about three main algorithms, right? The brute force one, a priori algorithm, and FBGRO algorithm. So in the first part, we look at the first concept is call it support, right? Support or relative support and absolute support, right? So you will see this term frequently in the tutorial questions. The support refers to what I mean is what I call frequent, right? How do we define frequent? So support refers to item set or items that are statistically significant, right? So typically we define what I call it a minimum support. What is it called? Yeah, so we have to define a minimum support, which indicates what we mean by frequent, right? Things that appears, but maybe once or twice in a data set. We don't find them interesting at all, right? So we are only interested in things that happen more, I guess, frequent, right? And one of the issues here is that in associated pattern mining, this is what I would call it a problem of selecting the best minimum support values, right? The issue here is that if you select a small minimum support value, then chances are you will see lots and lots of item sets, which might be really hard to see. You might struggle with interpreting them. But if you select a large a value that is too large, it might not return any item sets at all, right? So what is the optimal one? It will depend on each particular application, but something not too small, something not too large is the way to go. So support, relative support, and absolute support are the first few important concepts. The next concept, okay, some properties of support, right? So these are the two important properties. The first one is called support monotonicity, which means that if you have a two subset, a set I, and we have a set I and a subset J of I, right? So which means that every element of J could be found in I, right? Or J comprises of some items in the original set I. So we have the properties that the support of J is greater or equal than the support of I. It just means that if you're trying to find larger item sets, then it will be less likely to show as compared to the smaller item sets. That's what it means, right? The next one is the what I call it result of that property, that is have an item set which is frequent. Then if you construct a subset, right, out of that set, then every subset of it is also frequent, right? Frequent means that the support is no less than minimum support. Okay, that's the important property, and we will make use of this property in one of the algorithms that we'll discuss later. All right, this concept here is, I mean, it has been proved to be a little bit tricky by many students in the past, and this is what I call a maximal frequent item set, which means that it's not maximum, right? It's not about the size. It's about that it could not be a smaller subset, right, of any other frequent item sets. Okay, and in the video I explained that already. So you have eggs, milk, and yogurt, right? My question here is that can you find other maximal frequent atom sets at mean sub is equal to 0.3. All right. Has anyone looked at this question and got an answer? Are the maximum set at 0.3? Okay, I have an answer there from. All right, so Jack, you say Brad. Okay, Brad is okay. So Brad is probably one. All right, so we have Brad here. We have Brad here. We have. Unfortunately. Jack, bread is not maximal because if you look at bread, for example, transaction 1, right, we have bread and milk, and the other one we also have bread and milk, right? So bread is part of bread and milk, and whenever bread happens, milk also happens, right? And milk also happens outside bread and milk as well, and therefore bread is not maximal, right? It's a problem. So if you say bread and milk, then okay, that might be, yes, bread and milk might be, but did someone say bread and milk? Yeah, okay, bread and milk is a better answer because bread and milk happens twice, which is 40% or 0.4, right? And I don't think there is something bread and milk and something else. For example, the first one is bread and milk and butter, right? But the third one is bread and milk and egg and cheese, right? So they're not the same. Okay. All right. Yeah. So I can see some other answer here. Milk and yogurt. You can find milk and yogurt as well. So let me double check. Milk and yogurt. Sorry, milk and yogurt is not maximal. Whoever said that, milk and yogurt. Yeah, so unfortunately, milk and yogurt, right? Milk and yogurt is a subset of eggs, milk, and yogurt, right? So because eggs, milk, and yogurt is maximal, you cannot have any item sets constructed from the combinations of eggs and milk and yogurt anymore. Okay, that's a fact. So if you say, and same thing for eggs and milk, not maximal at all, because they are constructed from eggs, milk, and yogurt. Okay. Yeah, if you have something like cheese and milk, for example, yeah, cheese and milk. Yeah, if cheese and milk and yogurt or cheese and milk and bread and eggs, they are not maximal, then yeah, then they are maximal. All right, so that's an example of maximal. So make sure that you understand what maximal really means, because you will see that question in the test, and it is important that you differentiate between maximal and other concepts, right? Okay, maximal is done now. Sorry, there was a cheese and milk, but initially so wouldn't be. Okay, so sorry, what was the question? Let me go back to that again. Cheese and milk occurs in transaction 2D, so wouldn't be enough. Yeah, I said cheese and milk, cheese and milk, cheese and milk. Yeah, cheese and milk. Yeah, I said cheese and milk are okay. Yeah, but someone say eggs and milk are not okay. That's my point. Yeah, cheese and milk is okay because cheese and milk, at least you have cheese, right? Not part of eggs and milk and yogurt. So that they're okay. But let me say cheese and milk. Yeah, cheese and milk. Yeah, looks fine. Cheese and milk. Yeah, 2 out of 5. Yeah, so maximal. Yeah, cheese and milk maximal. That's okay. Next one is association rules. All right, maybe I stop there. I go to the tutorial question, right? So that's enough. Basic concepts. That's enough. We wanted to go into. Okay. Do you have any question with a lattice graph? Okay. Yeah. Feel free to ask a question about it. Yeah. I love questions. So, all right. So this is figure 4.1 from the textbook, by the way. Okay, how is the border determined? Okay, the border is determined by, right, depending on the what you call it, on the actual transaction, really. I mean, it's yeah, it depends on MinSub. Of course, it depends on MinSub, but it also depends on the transaction that you see, right? It's what I said in the video. It's just a property, right? The property of the border between frequent and infrequent item set. But obviously, the border, how can you find the border, is really depends on the value that you observe, really, right? You have the same number of symbols, but different transactions database, and you can have different borders. Yes, there is no unique border. It depends on what you observe. We can only talk about its property and its and the border and the maximal item sets. All right, does it answer your question? Okay, yeah. Now, okay, so I think that's enough. Association rule, maybe we touch on that later. Let's solve some tutorial question to make sure that you understand all the concepts clearly. So let me have a look at the first question. Oh, sorry, I got the wrong one. Okay, not this one. Sorry, I get another file. Tutorial, right? That is about association pattern mining, association. Okay, that's good. All right, so the support of the item set. I think that you can work out yourself, look up the lecture slides of the textbook, right? But we focus on the second part of the question. Discuss the value of the support when none of the transaction sets items are overlapping. All right, what I mean by that is, for example, right, it means that no customers buys any item that are considered, that contained in the other customer. For example, if you buy eggs and milk, and the next customer might buy yogurt and cheese, right? So they don't have any share items between them. All right, so the question is, discuss the value of the support, right, when none of the transaction sets of items are overlapping. So think about that for 1 minute, and then let me know what you think. All right, okay, so there's a question here. All right, so we talk about the support first. We not talk about frequent item set. So insignificant is not the right way to describe it. Yeah. But Eric, I think you're getting somewhere. Yeah. You getting, at least you're getting some part of it. All right, this question is very general, right? It just says that discuss the value of the support. It doesn't specify the support of what, right? So you have to cover all possibilities. That's what I want to emphasize here. So if you pick up, right, so from all items in a supermarket, right, you can pick a combinations of items, and you have an item set, right, and you have to work out the support of that item set. How many possibilities that you can have for the value of the support of any item set that you can possibly construct. So Eric, you have given there, so insignificant because all transaction will be 1/n, but that doesn't really answer what the questions ask you really. All right, so maybe what I Okay, lots of answer, none of which actually correct so far. All right, maybe okay. Yeah, Eric, I think you kind of get there. What is n? Okay, so let me no, wrong. Unfortunately, it's not correct. Yeah, that's better. All right, conversation, right? However, that's not a complete answer. So what I'm showing here is just to, because maybe many people may not see it clearly, right? So let's just say we have a supermarket, right? Has 4 items, A, B, C, and D, right? So these are the items of a supermarket. So in the transaction T1, for example, you have the customer bought A, right? T2, customer bought B and C, right? And T3, the customer bought D. Okay, so this is what the questions, it is describing. None of customer have purchased the same item. So in this case, customer 1 bought A. All right. So the question says, can you comment on the values of the support, right? So, for example, if you say support of A, right, that is one possibility, right? What about the support of B? Is another possibility. And what about the support of C, right? And what about the support? Okay, let me just support of D. Okay, and the next one is the support of AB, right? It's 2 items, right? And support of AC, and so on. You can, life goes on, right? More and more items, and support of ABC, something like this, right? So you have lots and lots of possibilities, and number of possibility is 2 to the power 4 minus 1, right? Which is 2 to the power 4 is what's that? 16, and minus 1 is 15, right? So you have 15 possibilities. So can you comment on, so you have 15 possibilities of the support values, right? So Eric, you say support is equal to 1, but I think the answer is, you're getting there, but the answer is not quite correct, and it's not complete. All right. All right. Okay, so from this particular example, right, can you tell me what is the support of A? I mean, relative support. Can anyone tell me what is the support of A? Yeah, 1/3, correct, 1/3, okay. What is support of B? One over 3 again, okay, yeah, correct. What is support of AB? 0, yeah, 0. All right, what is support of BC? Yeah, 1/3. All right, so from there, what can you say? So we can see that there's only 2 possibilities. One is, exactly, okay. So it is either 1/3 or 0. So my question to you is, when is it 1/3 and when is it 0? No. Oh, of course, yeah, 0, it doesn't occur. Yeah, of course, correct. Exists. Yeah. Okay, not clear. It's not clear to me. All right, so the answer is that there are 2 possibilities, right? If so given an item set, okay, if the items from that item sets come from the same transactions, right, then the support of the item set is 1/n. If the items within that item set come from different transactions, right, then the support is 0. That is the answer to this question. So we have to cover both cases, right? Okay, so if, right, I type it again. So if items, right, in an item set, right, come from the same transaction, right, then the support is 1/n. Yeah. All right. And vice versa, if items in an item set, right, comes from different transaction, then the support is 0. Put it that way. Okay. So or even none of the item set at all. Okay, so we have two concepts. One is called relative support, and the other one is called absolute support, right? So the support itself can be 1 if it appears. Okay, yeah. I mean, in this case, the support. I mean, we cannot say where the support it can be equal to 1, because if there is only one transaction, then it's equal to 1, right? So it's not correct. Okay, okay. So what I mean by come from the same transaction, for example, right? If we have an item set of B and C, right? So obviously, both B and C come from the same transaction, and it is transaction 2, right? But if we have an item set, say for example AB, for example, right? Whereas because A come from the transaction 1 and B come from transaction 2, so the support of this is equal to 0, because you have non-overlapping transactions. All right, does it make sense? Is it clear to everybody? Okay, so I hope it's clear, right? It's just that people forgot about the cases when the support is 0. They just think about 1/n, and forgot that support could be about other cases that, possibilities, right? Association. So that's the first question. Let's have a look at the second question now. The second question is, I mean, I think you can find it really, it's just a theory, right? Explain the support monotonicity property so that you can look up the slides or the textbook, right? And how it might be useful when developing pattern assertion algorithms. So doesn't anyone, so we focus on the second one, right? How it might be useful when developing pattern assertion algorithms. So can anyone answer now? Or maybe I can leave that later when we finish all the tutorial questions, and you can see the big picture a little bit clearer. All right, if anyone can answer now, I'm more than happy to hear, but otherwise I probably leave after we, Jack, if you can speak.
Yes, excuse me, so I'll take a stab. So it's used by the a priori algorithm.
Yeah.
And it takes advantage of that through, because this the support monotonicity property is a postulate for the downward closure property. And it reduces the size of the search space, so that's how it increases its performance.
Exactly.
Okay.
Thank you, Jack. I think that's the answer that I was looking for. So for those of you who watch a video and look at the a priori algorithm, you know that if you search for all possible combinations of items to make item sets, right, then you can see that the search space is really huge. So this property is used in the a priori algorithm. And the idea is that if an item set at a lower level is not frequent, right, there's no point of searching a superset of that item set, which means that items that are larger and consist of that item set as a subset, right? So we can see that a little bit clearer. Okay, question number 3, just on the topic of maximal frequent item set. Explain whether or not there could be more than one maximal frequent item set in a transaction database. Very simple, right? So when we say maximal frequent item set, is it only one, or there could be more than one? Yeah. So can you explain? Okay, of course, the answer more than possibly more than one is the correct one. But how can you convince, right? If another student in the class asks you this, right? How can you explain to that student? Yeah, correct. Yeah, yeah. So you can, one easy way, maybe you can use an example to explain, right? An example to explain, and yes, and yeah, and actually, if you look at the what I call the lattice, right? The borderline, you can see the borderline. If the borderline, cross the lattice, many nodes, and you remember that's the nodes next to the borderline, they are maximal, and there could be more than one if the borderline, cross the lattice, diagonally, and not in a corner, for example, right? Yeah. So whichever way you use, right, it's an open question depending on how you construct your arguments. All right. Does anyone, question number 4, doesn't anyone remember if I have absolute U, right, is a notation that denotes the number of unique items in a transaction database? How many nodes are there in the item set lattice? Yeah. Okay. Yep. So 2 to the power of U, absolute U, right? It's the total number of nodes, including the null one, right? So just to be clear, right? We mentioned that including the null node. But if you exclude the null node, then it is only 2 to the power of U minus 1. Okay. All right, so that's the warm-up exercise. Now I go back to the slides, and we look at the second part. So the basic concept, right? Support, maximal, frequent, right? So these are, and the properties. All right, now we discuss association rules. So what is the goal that we're trying to achieve here? The goal that we are trying to achieve here is that we want to assign some probabilistic sort of meaning to the statement, right? So when we say item sets or frequent item sets, then we typically refer to items that co-occur, and we mean 100%, right? So, but what if we want to have some probabilistic meaning or conditional, right? And then we need to use some form of a rule, and the rule is have 2 parts. The left-hand side is called antecedent, and the left-hand side is antecedent, and the right-hand side is a consequent, right? Now, you have to be very clear, right? What happened is that we, in the what's sort of Bayesian statistic, what we mean by the left-hand side X here is that some events that has already happened, right? And then we are interested in the event on the right-hand side, given that that the event on the left-hand side has already happened. So, for example, if a shopper buys milk, then what we would like to know is how likely is it that the shopper will also buy bread, right? If it is item set, then we can say, then in the previous case, we will look for milk and bread. But if we want to assign some conditional probability, right, then we say 90% chance that the shopper will also buy bread, right? So it gives more room to find out the relationship between different items in a transaction data sets, right? So a couple of more concepts. The first one is the confidence. So this is basically the conditional probability, right, of of X and Y occurring given that the transaction already contain X, right? So X has already happened. What we are interested in is how likely that Y will also happen, right? And because X has happened, so X and Y will also happen. So that is what I call the confidence, right? The confidence, we use this notation conf or from X to Y, right? So X arrow Y, right arrow Y, right? And this is basically the support of X and Y divided by support of X. Now, the common mistake in the previous year is a student forgot about which one sitting on the top, which one sitting on the bottom, right? Now, one thing that you might want to make use of is that the conditional probability is always less or equal than 1. So if you have something larger, right, it should sit on the bottom, and if you have something smaller, it should sit on the top. All right, so do not mix up between the two. Yeah, so support of X and Y. Yeah, so this is what we call a set notation, Eric. So which means is, for example, I show below, right? So if X and Y, then you can say, yeah, in the set notation, we have X cup Y, right? So for example, if you see down there, I have X is equal to AB and then Y equal to C, right? Then X union Y or X cup Y, whatever you call it, right, is equal to A, B, and C. However, you also have the case where you have X is equal to A and B, and Y is equal to B and C, right? So between them, you have B in common. So in this case, X union Y is also ABC. Okay, so I hope that notation is clear. It's just a matter of notation. X intersection Y on top. Conditional probability. Okay, so here, all right, so here that we have to work out the probability. No, I think okay. I think you all mix up, right? Because if you have only B, right? If you have only B, okay. So if you talk about the notation that you talk about is intersection, right, of X and Y, which is not correct, because the reason for that is that if you talk about X and Y in the first example here, you have A, B, and C, and then the X intersects Y will give you an empty set, right? And which means that you have 0 regardless of how X and Y happens, which is incorrect, because X and Y always happen 100%. Then X intersects Y is not the right way to define, right? So you have to have X union Y, unfortunately. When I talk about X union Y here, I'm not talking about the probability space. I'm talking about the set. I think you are mixed up between the probability space and the set. That's the problem, right? So you are referring to the diagram, the Venn diagram. I talk about the probability space, but here I'm talking about items. So they are totally different things. Yeah, but anyway, it's a good question. Yeah, it's a good question. Okay. Yeah, so Andy, your question is sub IBC, sub IB. Yeah, something like this. Yeah. So the numerator 1 should be the sub of item sets of everything, right? So everything that you can identify from X and Y, right? All the unique items, right? A, B, and C in the second case, and also A, B, and C in the first case. Okay, so yeah, very advice, right? Make sure that you understand which one should be on the top, which one should be on the bottom, right? Because frequently we I saw in the past test, people just have something 2, 3, right, which is not correct. Conditional probability should be some value, not more than 1. Put it that way. All right, and the association rules, all right, is this definition here is, so once you have the confidence, right, you can talk about association rules, okay? So previously we say item sets, and then we can define frequent item sets. Now we have mean sub, which is the threshold for something being frequent, right? We also have the mean con, which is something to make this, I guess, strength, right? How likely that it will happen. So we have relevance and strength. If we have both of them, now we can construct or define association rule, right? So association rules is always described in terms of the support and the confidence, right? So that is the extension that we need to be aware of. So when we talk about assertion rules, the first thing is that you have to define what is the minimum support, what is the minimum confidence, right? How we define as a good conditional probability, how we define something as frequent, okay? So similar to the other properties, now we have what we call confidence monotonicity properties. Now, I explained in the video already, but so I won't go back explain here. But if you find this concept hard, then I can explain again here. Okay, does anyone have problem with understand this confidence monotonicity property? Okay. Yeah, okay, so yeah, so let me just go through this again, because I think that is not something people can see it easily, right? And even myself, sometimes I have to be very focused in order to see the logic, right? So here we have, what does it mean is, remember, right? With the other properties here, sorry, what is it called? We have what's it called? The downwards closure. What is it? Did I have somewhere? No, I skip it. Downward closure properties. Yeah, here, right? So support monotonicity properties. So we have something, and we have something smaller, right? And we have some inequality concerning the support of these two sets, right? One, they are the subset of the other. But now we have the what you call it, the association rules, right? So what we are trying to establish in this case is to put it easier. Right? Look at the example. We have bread, butter, and milk. All right. So we have 3 items: bread, butter, and milk. All right, so we can say, well, if we can have 2. So from a supermarket point of view, for example, right, they are interested in 2 possibilities. The first possibility is a bread. If the customer has already purchased bread and butter, right, how likely that the customer also purchased milk? That is the first one. And the second scenario is that if the customer has already purchase bread, how likely that the customer will also purchase butter and milk? All right. Now the difference between these 2 cases is that you can see, right? As far as the left-hand side or the antecedent is concerned, the first case has more, right? Bread and butter, and then on the right-hand side they have only milk, right? As opposed to the second case, the left-hand side is smaller, bread, and the other one is butter and milk, right? Remember, bread is part of bread and butter. So there's a question is, which rule will basically give you a larger confidence score, right? So this rule, so this is what I call the confidence monotonicity property, is that if the left-hand side is larger, you have more item set, right? More items, in that item set, then the confidence is better, which means that yes, many things has already happened, so it will be more likely, as opposed to only few things has happened and you require more things to happen, so it will be less likely. Does it make sense? I'm not sure if I explained that clearly enough. Okay, so it's just concerned with, you know, if many things has happened already or only few things has happened, right? And you require few things to happen or you require many things to happen. Okay, so that's just the idea. All right, so okay, so we I'm not sure, look at, all right, we have maybe 5-10 minutes break for now. We are reaching over 7. Yeah, and in the meantime, if you can have a short break or you can look at the tutorial question. Let me have a look at this, see what question you can have. All right, you can have a look at question 5 if you have, during the break, think about it, and then we can look at question 5 after the break. All right, so I could see you in 5-10 minutes.
All right, let's see how many people are ready to continue our workshop. All right, yep, I have at least 17 out of whatever, 57. Let me get my other computer ready. Okay, yes. All right, let's go back to our workshop, everybody, if you're online. All right, now question number 5, right? Has anyone got any idea about this question? Explain whether or not the support of the consequent y is always less. Sorry. Whether or not, right, the support of the consequent y is always less than or equal to the support of the antecedent x. So you have x and y. They are on the left and the right hand side of the rule. Okay, so we know that the confidence is less than 1. Now, does it give us any information as to whether or not the support? All right, can we say anything about the support of y and support of x? How do they compare? All right, yeah, thank you, Jack. So what you are saying here is the statement is not true, right? If x and y are not overlapping, can you be more specific? I do not. I don't think I can interpret.
So just going off what you got on the previous slide there, saying that for a rule between x and y, they don't have to be overlapping. And if that's the case, then when you calculate the support, the support of y can be greater than the support of x. But maybe that doesn't make sense now that I'm looking at it.
I think it's very hard to say. For sure, if whether it's overlapping or non-overlapping. Does anyone else have any idea about how to answer this question? All right, Kevin said that y should be less or equal to the support of x because x must occur first. Oh, okay, that's a good point. X must occur first. Wow, that's interesting. I haven't seen that before. Why do you think x must occur first? Yeah, so Eric said it does not mean y smaller than x there. All right, so just to correct your understanding, Kevin, when we construct the association rule, right? We look at the probability that y will also happen given x has occur, right? But it doesn't mean that x happened first, or by the way, first or not first is not a relevant thing to discuss here. What we are interested here is basically probability of events, right? And then whether that has happened, first or not, then is not really a question. We are only interested in the event, and whether the particular event happens before, not really first, or in the sense of
of outside the statement, right? Is not what we are interested in. We are only interested in what's the statement or the assertion rules, right? Describes. Yeah, y might still be more frequent than x because y consists of many other variables here. So Eric, what is your point? So explain or not, right? How can you explain? Yeah. Okay. Yeah. So this is a very I suppose open. Yeah. I think you might be on the right track. But if I mark your answer in the test, I haven't been able to find anything concrete yet to give you good marks, right? I might give you some mark there. Well, so the answer to this question is that it doesn't matter, it doesn't mean anything at all, right? Because the rules is only concerned with, let me put it this way, the probability of x union or the support of x, right? Union y divided by support of y, so x, right? Now, even though this is less than 1, right? Even though this is less than 1, there's nothing we can conclude about whether support of x and support of y, which one is bigger, which one is smaller, right? It depends. It depends on the observation, right? On the transaction that we observe. Some cases we may have support of y less than support of x. Some other cases we may have support of x greater than support of y. So the confidence, the fact that the confidence is less than 1 doesn't imply anything at all. Okay, and you can give an example. All right. So the answer is that there's no conclusion. Yeah. Okay, so the confidence of x and y is 1, right? Would that make them a subset, and then the support must be? All right. So what about the case when the confidence of, okay, that's a very special case. If the confidence of the rules, right? If the confidence of the rule x, for example, to y, right, is equal to 1. All right, so what can we conclude about this, everybody? X and Y always occur together. X and Y always occur together. Not correct? Eric, that's actually not correct. They always occur at the same time. No, not correct. They are always associated. Not correct. Exactly. Yeah. If X happens, then Y always happen. Okay. So if X happens, right, then Y will also happen. But the converse is not true. If Y happens, it doesn't mean that X will happen. So in this case, right? Yeah. So if X happen and Y will also happen, then we can say that the support of Y, in this case, the support of Y is greater or equal than the support of X, because the point is that whenever X happens, Y happens, right? But maybe Y happens, but X doesn't happen. So so there may be cases where Y happens, but X, doesn't happen. So if the confidence score is actually equal to 1, then it's the special case, and we can conclude that the support of Y could be greater than the support of X. But it's only in a very special case, right, where the confidence is equal to 1. Less than 1, we cannot say anything for sure. All right. All right. If no further questions, then I move on to the, let me check. The next question is, okay, the next one here. What's the next question? All right, let's now look at the All right, and let me just cover this a priori algorithm first, so that we can solve question 9. Where is it? Where is it? All right, so we have the confidence, the concept of confidence. We have the concepts of, all right, so the algorithm. All right, now there are 3 algorithms that we discussed in this lecture. The first one is a brute force algorithm. So from the slide and from the video, I mentioned that if the number of items in a transaction data set is really large, for example, you can talk about 1,000 different items, then if you try to enumerate all possible item set, it will just be too much, right? And even existing computing power was struggle with calculating all the item sets. In terms of memory and storage, it's too huge. So we cannot really do this way, right? And therefore, brute force algorithm can only be done manually, maybe very small problems, typically, in a very small settings. So how can we come up with different algorithms that perform better regardless of the size, right? So one of the algorithm is a very early algorithm in this area is called the a priori algorithm. What it does is that it exploits a downward closure property, like what I said earlier. The key idea here is if a candidate item set X does not meet the support, right, then any superset of X will also fail. All right, one thing that you might ask is, what do I mean by a candidate item set, right? Then it explains in here. What do I mean by candidate item set is, all right, let's just assume that we are looking at level 1. And in level 1, you can see that, we can look at A, B, C, D, and there for each of the node there, we just write the number of occurrences in the data set. For example, A has been observed 4 times, B 6 times, C 4 times, and so on, right? Now, if A is a frequent item set, then from A we can generate AB, AC, ID, IE, right? So AB, AC, ID, IE, they are the candidate item set. What does it mean by candidate item set? Is because we think that they are the possible frequent item set, but we can only conclude that they are frequent when we actually check the number of occurrences in the data set, right? So initially they are candidate, right? Because we haven't checked yet. But once we have checked, then they can be, right? Each of them can be either infrequent or frequent, right? So the term candidate, it just means that an item set that we haven't checked yet, all right? And this is a feasible one, right? It is, all right, so, but if, right, for example, at level 2, we have IC and we have already ruled out, right? And if we say that this is definitely not a frequent item set, it's an infrequent item set, then ICD, right, as you can see from the level 3 there, is not a candidate. It should not be there at the first place, right? Because IC is already infrequent. All right, so frequent, candidate item set is a superset of an infrequent item set, right, at the lower level, and it just means that we haven't checked the number of occurrences yet. Okay, so that's the main point I want to say for the a priori algorithm. So how does this algorithm work? It's start from level 1, and it will just keep going and going until the largest possible level, right? Of course, what level it is, and it depends on the transaction. Typically, you can go to the maximum number of different items in the transaction data set. However, obviously, you need you might not need to, because if you can look at the transactions in a transaction data set, right? Which transaction has the largest number of items, you can stop there, because we don't observe anything more than that, right? For example, if you have maximum 6 items in a transaction, then you should not go more than level 6, right? Because it is a 0 probability that you can find something else like 7, 8 items in an item set. So the process is as follows. First of all, we start with a 1 item set, right? And then we try to filter out all infrequent item sets. And then we combine 1 item set to create a candidate 2 item set. And then we search through the transaction data set database, and then we decide which one is frequent and which one is not frequent. Okay, and we keep going. And yeah, and that's the idea of the a priori algorithm, right? And therefore it's called the level-wise algorithm, because it performs at each level at a time, right? And it moves to the next level when it's finished the current level. All right, the second algorithm is, I hope that you have gone through the exercise or the example that's shown in the slides here, so I won't have to go through, right? We focus on the particular problem. The FP-GROW is another approach to finding frequent item sets in the transaction data sets. And the difference to the previous algorithm is this, right? It's used what I call a tree structure to process the transactions database, and it's called FP tree. The key thing is that each node, right, now represent basically an item and not item sets. That's a key point. That's a very key thing, right? So if you look at the previous one in the a priori algorithm, you can see each node here represent a possible item set. But if you look at the FP tree, which is here, for example, each node here is just an item, right? Item set can be constructed by traversing through different parts of the tree to find out the frequent item sets. But each node itself is just an item. Okay, that's a very, very important property. Each node has associated with them some number, right? And that number is calculated or accumulated by going through the transactions, and every time you observe and every time you pass through that node, you have to increment the node by 1. Okay, so that's the idea. So how do you construct the how does this algorithm work? So first of all, you have to I said in here, you have to reorder, right? Reorder the items depending on which items appears most frequently. For example, the original order is A, B, C, D, E, but because B appears the most, right, 6 times, so we would like to write instead of A, B, D, E, we would write B, E, I, D, right? And therefore, that's why you can see here B, E, I, D. That's in the first transaction. So it's just the same set of items, but we just reorder the item in such a way that it helps the constructions of the FP tree, which is part of the FP-GROW algorithm. And then we keep going and we keep expanding the branches, and whenever that we cannot find the relevant node, right? And then at the end of the algorithm, you can come up with this tree. So that's the idea of this algorithm. Is there any question about this algorithm or the a priori algorithm before we move on to the tutorial question? All right, so if there's no question, then now I go back to the tutorial question number 9. Okay, so get your All right. Now the first part of the question should be easy. You need to work out the absolute support of AEF and DF. So I give you perhaps 1 minute to work it out, and you can tell me the answer. Oh yeah, are we on question 9? Yeah, Eric, we just solved question 9. Yep, question 9, please, everybody. I'm not sure if I make myself clear. Mm-hmm. All right, I have some answer there. The absolute support, they are, yep, there are 2. Yep, this is 2. Yeah, for the first one. What about the second one? DF? How many times? Yep, so there are 2, right? So for IEF, the absolute support is 2, and for DF, the support is also 2, right? How can you convert from absolute support to relative support? Yep, 2 divided by 5. Yeah, 0.4. Okay, that's really good. Now, the next thing is, can you compute all frequent patterns at absolute minimum support of, let's just say 2 first. That's a bit of exercise, right? So what I am suggesting you to do is to I guess the way that I suggested in previous year, right, especially when it comes to answering the questions in the test, is to write on 3 lines, right? The first line is level 2, the second line is level 3, and the last line is level 4, right? And then what you could do is that you can at each line you can enumerate all possible items, right? Of course, when you look at the a priori, then it's not all possible one or the candidate one, and then you can indicate the counts, and then you can either underline, or maybe underline is better, but maybe if you are typing in, then maybe put in a bracket. It's probably easier to recognize which one is not. All right, it is infrequent candidate, but infrequent. Okay, so I will show you as an example shortly. So what I mean here is this, because since we are having a test online and you have to type in, right? So the easy way for me to see your answer is to have some consistent way of doing that. What I mean here is this. So if I were answer this question, right, I show you first and you can complete blank whiteboard. Yes. I hope you have this question now in front of you, right? Because I have to use a whiteboard. So let me just check. So what I want you to do is a basic level 1, right? And normally you would write how many items are there. You can have A, and then you can have okay, so open bracket, whatever. So you have to find out how many times A appears in the transactions, and my observation is that there are 3 of them, right? So A3, you can say A3, okay, and then you can, next one is B, and then you have to end the time. Oh, how can I make it bigger? Oh, sorry. Oh, sorry, I make a mistake there. Clear.
All right, so the first one you start at level 1. Oh, it doesn't make longer. Okay, level 1, right? A, 3. Right, B. How many times do we have for B? 1, 2, 3. Is it 3? Yeah, okay, yeah, so I hope that's correct. C, we have how many times? 1, 2, 2, right? Yep, and D, how many times do we have? 1, 2, 3. Yeah, E, 1, 2, 3. I think I'm on the right. 3, and F, is it 5? 4, 5. 1, 2. Oh, 4. Yeah, 4. Okay. So so this is how I would like to see in your answer. If you have to type in, this is the best way, right? Now the next one is level 2, right? So with level 2, the way that I suggest you to do is this level 2, for example, right? Since there are many things, I always suggest you to start with like A first, for example, right? You can start A and then you have, right, for example, AB, right? So you have to write something in here, and then AC, something in here, which I haven't filled yet, right? ID, something in here, IE, something in here, IF, something in here, right? Now, once you finish A, do not go on, right? Move to the next line, right? But it's still within the L2 level, right? The next one is BC, right? And then BD, for example, BE, and then BF, right? That's how you should try. And then when you finish B, you move to the next one, CD, CE, CF, right? In the test, I won't ask you that up to F, but probably it's to DE, probably that's enough. And then the next one is CDE and DF, right? And the last one is probably EF. Okay, you have to fill in all this entry, right? Now, this is a part if you are not asked to show the candidate item sets as in the a priori algorithm, right? However, if I ask you to show the a priori algorithm, right, the way that I expect you to do is this. So if I have level 3, for example, right, and this at this level, for example, if I for example, it's not correct, right? But maybe EF or EF is more. For example, if no, I don't need to order. As long as you follow the exact order, is much easier, because from a marking point of view, then I can see that much easy, right? Yeah. So that's not really good. All right. So this is one example, right? Now this is the example where you have to enumerate all possible item sets. However, if you are asked to show the a priori algorithm, right? I suggest this is the way that you can do. So you have, for example, L1, right? Let me just talk about another scenario, not exactly the same here. For example, I3, for example, but B, for example, maybe you have 1, for example, right? And C, maybe you have 4, for example. Now, after you have done this, and then you say, for example, if the threshold or the mean sub, right, is equal to 2 or absolute 1, right? If you can put this one in a bracket, square bracket, for example, if you're typing, right, maybe that's really the easiest way. Underline, I'm not sure if you can underline using text, so probably something put in a bracket. So if you put it in a bracket, it means that it is not frequent. Whatever remains is basically frequent. Okay. In the past, right? Sorry, not in the past. Last year, I asked students to underline, because that's when they write the answer on a piece of paper, right? But I don't think we can underline easy if you have to type in text. So I suggest that you use a square bracket, so that you can you mean that B is infrequent, right? And therefore it might affect level 2. So level 2
If it is a case, then for example, L2, for example, L2, you only have IC, right? You cannot have IB because B is already infrequent. So IC, you can only have IC, right? Is a possible candidate, right? Of course, then you have to work out whether IC equal to 3 or IC equal to maybe 1, right? If it's 3, then you leave as it is, but if it is 1, then you also need to put a bracket because remember that the threshold is 2, right? So if that's the case, okay. So I hope you understand the possible notation that you can use to answer this type of question in the test. All right, so I leave you to continue your work on this question, and those of you who finished the frequent patterns at minimum support 2 and 3 and 4, you can send me a private message and I can tell you whether you got it right or you got it wrong. Okay, it should be okay. Okay, I have some answer here. Give me a bit of time. 3, A, B, E, F, E, F. Okay, yeah. So far, yeah. A, B, C, D, E, F, F, A, D, R. Okay. I have a question from. Could you explain again in the second L1 you wrote where the number have come from? I mean, okay. So now I think it's just a made up example for the a priori algorithm, right? It's not part of question 9. Yeah, it's just meant to show if you have to show the candidate item sets and the frequent item set in each level-wise part of the a priori algorithm. This is how you should write in the test, because with the candidate item set, right? Yeah, you have to, as I said before, in the previous year, student underline to show that this item set is not frequent, right? Which and the remaining ones are frequent. However, yeah, because you have to type in the answer this semester, so using a square bracket to indicate that that frequent that item set is a candidate, but it's not frequent. It's just a notation only. Okay. All right. So this is A, B, C, A, B. D, E, F, B, C. All right, I have one answer so far. Has anyone else managed to find out all the frequent item sets? All right, so I have another one. Yeah. Yep, so I have ID, IE, IF, AVC, BD, BF, yeah, D, D, F, E, yeah. Which is 3. Okay. All right, I have received more. All right, let's check. All right. Can we please work on the assumption that the median support is 2 for the moment, right? So 2, 3, and 4, but 3 and 4 you can follow the same thing and maybe do it outside the workshop. Maybe we focus on mean sub equal to 2 first, right, to make it consistent across the class. And 2 basically it's is the longest answer, so is the hardest one. 3 and 4 should be much easier. Maximum support to no. Okay. Oh yes. So let me just try A B. Okay. Okay. All right. All right. So what I'm going to do now is perhaps I just post the answer here for people to cross check, right? So first of all, I post the answer for people to cross check the they want. So I'm working on the mean sub is equal to 2, right? So at level 1, you should have A, B, C, D, E, F, right? So no question about that because they are more than 2, right? Each of the one at L2, right? So the first one you have AD, AE, AF. right? That first of all, for A, right? Then you have BC, BD, BF, and then you have DF, and then EF, and IEF. So I purposely split them into different lines, right? Because the sorry, the last one should be L3, right? Not IEF. Sorry, my mistake there. I split them in different lines because easier to see the combinations of items. All right. So if you have this answer, then you're on the right track. I can see that people send me answers. So yeah, yeah, that's also fine. Yeah, that's also fine, Eric. If you write that way, as long as you have a clear idea in your mind, right? Make sure that you don't miss anything. The way I write there is to help you, right? Keep track of the items sets because typically when people keep writing and then somehow they miss a few things, right? So based on my experience, I suggest that people split into different lines and then make sure that you don't miss anything. People do tend to miss few items there, and yeah. Okay, because when you write down, but then when you write back, then yeah. Okay, so that's the answer. The next question is all right. Focus on mean sub equal to 2, right? Can you work out the maximal frequent patterns or maximal frequent item sets? So maxi. All right, some people have sent me the answer, but unfortunately not correct. So you have to try that again. That's not enough. All right, so I'm going to show you how to work out the maximal, right? At least one possible way, because people might not be clear how to define the maximal frequent pattern. So what I'm doing now is that I'm just reproducing what I wrote in there. So with okay, I write text first, right? So from the previous part of the question, right, at mean sub equal to 2, I have at level 1, right, is what I have here. Oh, I have another answer. Yeah, Ben, I will look at your answer later because I'm going to give the example to the whole class because I don't think this question is this part of the question is easy for many. So I'm listing the one that I show you A, right? It might be B and then C and B and E, and then F, right? So it's a level 1. All right, so level 2, I have, at level 2, I have ID, and then IE, IE, IF, right? I also have BC, BD, BF, right? Here I have DF, okay, just follow the same EF, and then level 3, I have IEF, okay? So let's stop for a moment and think, right? Maximal frequent patterns, what is the best way to find out the maximal frequent patterns? My advice to you is that you always start from the highest level, right? Because you know that the maximal frequent item set, by definition, is the set that is not included, right, by other sets. And therefore, it's natural to think that you start with the largest one, because the largest one is not is unlikely to be included in any other item sets. So if we, for example, start at level 3, for example, right, IEF is tick. This is good. Okay, so that is good. All right, then we go down to level 2, right? So EF. All right, so let's stop working for the moment and answer my question. If IEF is maximal, right? Should EF be maximal or not? So we can ask ourselves, yeah, is it part of this, right? So obviously EF is part of IEF, and therefore so we can say, well, no, this guy cannot be a maximal, right? So we can rule out EF. DF, can it be part of this? Is DF part of IEF? No, right? So it looks like, okay, so it's okay. It's a maximal, right? It cannot be, and DF cannot be a subset of any other item set at level 2 or level 1. That's for sure, right? So we can say, well, this guy is good, right? And then we can check BC is a part of IEF. The answer is no, so it's good. BD is also good. BF is also good, right? IEF, no, because IEF is part of IEF, right? Even though that E is in there, but remember the IEF or IFE or EIF, they are just the same, right? We just write in the particular order that make it easier for us to track the item set, but the order of the items in item set is not important, right? And therefore, you can say, well, IEF should not be included, and so is IE, right? But ID is good because ID is not part of IEF, which is at a high level. So give the green light there. All right, now we check the first level, right? I, should we keep it or should we cross it? Yeah, cross it, right? Because I is part of IEF anyway. B, should we keep it or should we cross it? Cross, right? Because B is somewhere there. You have BC, BD, right? So remember, at level 2, we have identified that BC, BD, BF, right? B is part of BC, BD, BF, and therefore B, C, D, A, F should be, and then we have D and F should cross out as well, and we also have BC here cross out as well, and IE there, E is already there, so E cross out as well, right? So whatever the items set that are that come with green ticks, for example, then we can say they are maximal. That's the process. Okay, so we have IEF first of all, and we have ID, BC, BD, BF, and DF. Okay, does it make sense to all of you? All right, so it's 8:10 now. We have a break for 5 minutes, and after which I will go through the a priori algorithms and make sure that we can understand that. So, all right, you can have a short break.
All right. So when we have a short break here, does anyone want to ask any question? Maybe, yeah, maybe up to 8:15. Yeah, Eric. Yeah, 8:15. You can come back. Yeah, Kevin, I think that's should be the way to go. Yeah. If you want to calculate the frequent patterns or the prior algorithm, you start from level 1 to level 3. But if you want to work out the maximal, then I mean, you should start from the level 3. I mean, you can start from level 1, but then you need to perform more checks than as compared to when you start from level 3. For example, you can say, I can start from level 1 and look at A level 1, for example, right? And I say, is a possible maximal frequent items, maximal item set? Then you have to check a level 2 to see if you have found anything, right? But if you cannot find anything level 2, then I'm not sure if you have to go level 3. Oh yeah, so maybe level 2 is enough. So you have to check, is A part of ID? So yeah, you found ID, then you can cross out A. So that works also. Yeah, but maybe I think that maybe you have to do more checks. That's my feeling. But yeah, top or bottom, maybe might work both. Oh yeah, so minimum support of 4 means the items or the set of items, right, need to appear at least 4 times. So including 4. Okay, so it could be 4 or 5 or 6. Okay, so there is a question there, and the question is the first test will be a question that require Weka or Python. The answer is no. I do not expect you to use Weka or Python, right, to do the test. It is yeah, it is totally. I mean, in the past it's written based, right, but now typing rather than. Okay, I won't ask, specific filters in Weka or, Python methods, right? That you do things, but it's the test focus on your understanding of the topics that we discussed so far. So the practical skills are really assessed in the assignment, right? So what you do with the data is, assessed through your, practical skill, right? Assessed through the what you do with the data in the assignment. All right, so I hope people have, I suppose, copy the one that I wrote, because I'm going to erase the screen now. I have space for the
a priori algorithm. So, okay, so with the a priori algorithm, right? Let's work together, right? Let's work together. Maybe it's more, I guess, more productive. And once you know the idea, then you can repeat the same thing with different support. Minimum support value, right? So let's just work again back to the same thing, but now, but you may have sent me your answer to the questions, about frequent patterns before, right? But what you did in that part of the question is to simply enumerate all possibilities, right? So it's simulate what we call the brute force methods. So you list all possible item sets at level 1, level 2, level 3, level 4, and at each level you count how many items are there, and you from there you can select the one that that is at least, right, means up, right? So that's the way that that we did in the previous part. Yeah, sure. Now for the a priori algorithm, right? I have to write here now. We have the a. Okay, so if you ask this kind of question in the test, for example, right? This is what I expect you to produce. So let's first of all, let's work at level 1, right? So the same thing as before, we have level 1. So if you can give me a hand if I write things now. So level 1, for example, right? I have A, which is, I can't remember how many items are there. 1, 2, 3, the 3? Okay. Yes, so Y3, B, 1, 2, 3, right? C, okay, so C, how many are there? 1, 2, is it 2? Okay, yeah, 2. Okay, D, okay, thank you. Yeah, thank you very much. 3, E, 3, right? F, 4. Okay. Okay, so we have to. All right, so we check that they all greater than 2, right? So they are accepted. So we don't have to use any square brackets at the at level 1. All right, are we happy with that? Now at level 2, because level 1 we have everything. Every item set at level 1 is frequent, right? So we have to unfortunately list all the possible ones. So they are candidates. So IB. I do not have a copy of this. I don't have it in front of me. So IB is what's it? All right, yeah, thank you, Ryan. Maybe I just copy and paste yours, much easier. Maybe, how do I copy the comments here? Okay, IB, IC, ID, IE, IF, yeah, thank you. Okay. And then the next one is BC, VD. Okay, here. And then next one is CD. Okay, and DE. All right, and the last one is EF, right? EF 3. All right, so this is level 2, right? Now we have to do something about this. So I'm going to use a, okay. So we have to go through this, right? So they are, first of all, they are candidate item set. They are possible, right? But now we check that IB is equal to 1. So what I would like you to do in the test, right? So let me check if it works. Okay. So you have to put maybe, go back to the color one. So you have to put a square bracket here, so something like this, right, to indicate that IB is not frequent. Okay. Similarly, you can put a bracket here. I should type it, but I think I have a little bit of type space here. Okay. Now ID, because ID has two counts of 2, right? So should leave it there, and we look for things that are 1. For example, this guy 1. Sorry, I should use my touch screen, but I use a mouse, so it's not very good. Anyway, you get an idea, right? So this is where you have to put the square brackets. All right. I hope it's clear to everyone. I don't have time to cross out the put the square bracket next to the one has 1 car, but I hope you get an idea. All right. Now, this is now what we have to discuss. What about level 3? What should we put here if we need to show the a priori algorithm? Okay. Now, let's start with A and AB first, right? So, do we have anything to do with AB? No. Okay, Eric, no. Yeah. Why do you say no? Okay, because IB got eliminated, right? So it's not a frequent element. So anything to do with IB, right? We don't have to write out anymore. So something like IBC, IBE, IBD, IBE, IBF, right? So anything to do with IB, not anymore. What about IC? Can we have something start with IC? No, okay, because remember, is right. What about ID? Yes, okay, so what should we write there first? IDC? Can we write IDC? All right. Yeah, Kevin, yeah, you are right. We cannot even write IDC because IC already eliminated, right? I think, but by the way, we need to have, I think if you have a consistent ordering, I think you should have with ID, maybe you have to say IDE, IDF, right? All right, what about IDE? We write, can we have IDE as a possible candidate? IDE, my question is IDE. All right, William, you say yes, and now you say no. All right, should we write IDE down? Okay, so this is the thing, yeah. All right, so in order to write IDE down, right, you have to check, right? So IDE, we have to check, is it IDE okay? Okay, and then we have to check also check, is it IDE okay? And then DE okay, right? We have to make sure 3 of them are okay before we can write down. Okay, so in this case, DE is not okay because IDE has a count of 1, right? So you should not write IDE down at the first place, because the moment you write IDE down, I will deduct 1 mark straight away, right, from your answer, because it means that you didn't see the point of the a priori algorithm, because the a priori algorithm basically reduce the search space, right? And if you have IDE there, then it won't give you any mark. Okay, so I hope you see the point, right? So we have to, every time you write something down, you have to perform a little bit of check, right? And check by looking at the result that we have produced over there. And of course, because I haven't put a brackets on DE and DF and so on, right? Sorry. No, so the question from Olivia is that level 2, right? Remember, level 2, because level 1, we have A, B, C, D, E, F, right? They are all frequent. So everything, every possible enumeration in level 2, we have to write them there, right? The only problem is level 3, because why? Because in level 2, we have quite a number of item sets which are infrequent, right? They have the square brackets, right? So that we have to be careful when we start level 3. Okay, that's the difference between level 2 and level 3. All right, so IDE is not okay. What about what do you call it? IDF. Can we write IDF? Can you double check? All right, so to write IDF, we have to check ID. ID okay? Yeah, it's okay, right? IF, is it okay? Yes, okay. What about DF? Is okay? Yeah, so IDF is okay to write down, okay? So at least we have something IDF, right? Of course, if you can tell me IDF, how many cows are there? It's only one, right? I suppose. Okay. Yeah, only one, right? All right. So ID, we're done with ID. IE, right? Is there anything we can combine with IE? So we can combine IEF, right? IEF, because remember, if we follow the correct ordering, then we can only combine with the symbols or character after E, right? Not before D, because everything already covered before. So IEF, so we check IE is okay, yeah, IF okay, EF okay, so IEF is okay, and it has a count of 2, I suppose. Okay. So we are done with level, done with A, right? Is there anything else? We can start with B. All right, BC. First of all, BC, right? So let's just start with BC first. If we can see any possible combination of BC, so we can have BCD. No? Yes? No? Olivia say, do we not do IF? All right, because remember, IF we cannot combine with anything else to make 3. I'm not sure if you see it, right? IF combined with what, right? Yeah. All right, so we're talking about BC, right? BCD, no? Okay. What about BCE? IBF, yeah, IBF is eliminated, right? Because at the first place. Okay, there are too many comments, right? Can we focus on, okay, so BCD is not working. What about BCE? BCE, no? Yeah, because CE is 1, right? BCF, no, because CF is there, okay? BCF is 1. So we cannot do anything about BC, right? That is okay, so we cannot write anything to BC. And then BD is obviously nothing, we cannot start with BD, right? Already eliminated in above. We cannot start anything with BE at all because, again, problem. BF, we cannot do anything about BF because end of the list, right? So we cannot write anything to do with B at all. Okay, are we all happy with that? Okay, nothing to do with B. What about C? Right, so we can have CD, no. CE, no. CF, no. Right, so nothing to do with C at all. Right, C, CE, CD, CE, CF, they are all, you know, infrequent. Okay, what about D? Can we write something about D? D, DE, no. DF, yeah, no, DF end of the story, right? Because we cannot combine DF with anything else. So the conclusion is we cannot write anything else, right? Apart from IDF and IEF, right? They are only the, so you can see, right? The point that I'm trying to show you here is how much the how much search space that the a priori algorithm has reduced, right? Before you possibly have to enumerate lots and lots of possibilities, but now it's only 2, which means that this algorithm is very powerful, right? Okay, yeah, so now we have listed, right, and we count, and the next thing, yeah, I agree that you have to do is that you have to put a bracket here and a level 3 to complete it, right? We have a bracket here just to say that, well, this algorithm, yes, so that is done. We go up another level. Yeah, can we go up another level? You can try level 4, but I don't think you can find any combination at all. Okay, you can, because the only one, right, we can build from is IEF. Okay, and let's double check, right? Double check level 4. Can we actually level 4, for example? We definitely need to have IEF with something, right? So yeah, so we can say ABEF. We can try to have B in there, ABEF, like this. Is it possible? Can you tell me IBF? No. Yeah, no, because IB, yeah, IB is eliminated up there, right? What about ICEF? Yeah, no, because IC up there, right? IDEF? No, because IDF already eliminated, right? So nothing we can do about level 4. Yeah, nothing we can do about level 4. So level 4, we should not have level 4 at all. Okay, so we left with this with this. All right. Are we all clear on this, or is there anything else you want me to explain? Some of you may not see why I put brackets on something, or maybe I didn't put I didn't produce some other possible item set. But if you have any questions, let me know. Yeah. Oh, good. Okay. So let's now have a look at the next part of the question. This time we show the FP tree. Okay. So once again, I think better work together, right? Because for the first time you do it, so maybe I follow the same approach, ask the questions, and then you can comment. And okay, how do I clear it? Okay, clear. Okay. All right. So can you tell me from the previous part of the question, right? Which characters or which item appears the most, or we have to reorder them? So we have to reorder them, really. Yeah, F, right? So we start with F, right? Maybe I have to use another. So we start with F, which basically 4 times. Is it 4 times? 1, 2, 3, 4. Yeah. What character should we have next? Something happened 3 times. Is it B? Yeah, I, B. Yeah, whichever. Okay, they all 3, right? Except C is 4, right? C is 2, right? So A 3, B 3, B 3, E 3, right? C 2. Okay, so we just write down this so that every time. Of course, some of you might ask, right? Can we change I to B and B to I, for example? Yeah, I mean, as long as they are, they are consistent. If you swap I and B, you might produce different trees, of course. But if we don't have any further knowledge, then it's hard to say which one is better than which one, right? Of course, at the end of the day, we would like to have as compact as possible, an FP tree that is compact as possible. But the algorithm, in the algorithm, it doesn't really specify how to select the right order of the symbols, right? FP. Okay, I think FP stands for frequent patterns. That's what it means. I think so. Frequent patterns is that's sort of it to me, but I can double check. Okay. Okay. So we have F, A, B, D, E, C, right? So that's what we have to remember. The first one. So transaction 1. Can anyone tell me if we use this order of the items? How can we write the first? How can we write the first transaction? Start from here, maybe. So the first one in the question is say A, B, C, D, right? What should we write? Oh no, the first transactions, right? Okay, no, not that fast here. So if we have the transactions, which is at the moment I, B, C, D, right? But this is the original order, right? But now we have to follow the F, A, B, D, E, C order, right? How can what is the best way to read? Yeah, I, B, D, C. Yeah, correct. Yeah, that's what I expect. I, B, D, C. Right. So that is the first one. Oh, okay. Sorry, Olivia. Sorry, I thought you were talking about the tree already. So this is the transaction first, right? So what about the second one? What should we write in the second one? I write here so that we can construct the tree. The second one is IDEF. What should we write now? Yeah, FBEC. FBEC, probably that's a better way. Hang on. IDEF, why BC? Did I get it right? IDEF. So we should have F first. F first, right? Yeah, F I D E. Yeah, that's better. All right, that's the third transaction is B C D E F. So B C D E F. All right, as usual, F has to move first, right? Then B. Right, C has to move up to the back, and D E, right? F D B C. Correct? Am I wrong? No. F. Oh, okay. Oh, okay. Sorry, everybody. I look at the wrong. I think I look at the question 10. Okay, yeah. I'm sorry. Okay. Okay. Cross this out. I think I look at the wrong question. Really. Okay. The second one. Okay. Wrong question. All right. So what is the second one? B, C, E, F, right? B, C, E, F. All right. B, C, E, F. That would be F. F. Something like this. Okay. Yep. So I hope I got it right. The next one here is what do you call it? IDEF. IDEF. Okay. And then we have to move F in front and followed by I, followed by D, followed by E. Yes. All right. I guess 3 is enough, right? Because I think from the tree that I have here, yeah, it has 2 branches at the top, so that's very enough. All right, so the first one, right? If we have seen the first transaction, right, we have to draw a circle, right? So that could be a null node. Oh, okay. And then we have another one here is, oh, how do I move this one? Okay, can I make it bigger? Okay. Okay, so this is the null node. So I just use the symbol. Oh, I don't know how to write the null. How can I write here? No. Oh, this is bad. Okay, so okay, so this is null, right? So what should I write in here? This node here. Now, for example, oh, this is not good. Okay, let me try to think what's the best way to draw. Yeah, okay, give me a second. I need to use my other computers. I have 2 computers here, and the other one has a touch screen, so maybe it's better than this one. if, okay. All right, so, okay, how do I do this? Can I write on this? Yes. So the first one here is, oh no, like this. All right, I redraw the first one. I think I can do it. Oh, does it have some? Okay, yeah, never mind. I have freehand now. So first one here, right? This will be number one, the first transaction, and then you have what you have in. Oh, what you have here. What is a note that you write in here? That will be F, right? Oh no, the first one is I, right? If I that's I, yeah, I1, yeah, that's will be I1, I and 1. Okay, and the next one here is what do you call it? B, right? 1. And next here is D, 1, right? And the next one here is C, 1, right? Sorry, my handwriting is not good, but you get the point. Okay. All right. Are we all clear? All right. Now, if we go to the move on to the second transaction, right? What should we do with this graph? Now we have F, B, E, C. What should we do? Yeah, we have to add the second branch, right? So that is the main point. So we have to add the second branch. So this happened at the second one. So we have to draw a second branch, and we have a note here, and the note here, yeah, from the now, right? Remember, from the now, not from I, from B, from C, right? So the first thing is that actually you have to increase this one by 1. So now it become 2, right? Instead of 1, it become 2. And then here, what should I have for this note? What character should I use? F, right? So F here, is it 2 or is it 1? 1, okay, not 2, right? 2 is just the transaction from the now, but now this is the first time we create a node, and the first time we go through the node, so it has to be 1, okay? And then we create another one here, which is B, and then now is it 1 or 2? Some say 2, some say 1. Okay. We have observed B twice. Yeah, Olivia, correct. Yeah, but even though we this is the second time we observe B, but as far as this branch is concerned, this is the first time B absorbed in this branch. Okay, so we still have to write as 1. Okay, make sure that you are clear, right? Don't mix up with the B from the other branch, because it's not correct. And then E here, of course, is 1. And of course, the other one, right? I hope you can finish the C on the bottom. Okay. Are we all clear on that? Now, the next one is FADE. Okay. Do we need to create another branch? No, right? Because F is already there. Okay. So we can just go to F, and then we change from 1. Yeah, maybe I use another color. We change 1 to 2, right? Because now we have to increment the count of F. Okay, and then the next one is FA, right? What should we do? Yeah, now we have to create another branch. So that's what this algorithm really means. So we create another one from here. We create this is A, and this is 1. Okay, FAD. So similar here, D. 1, okay, and then whatever, E1 on the bottom. All right, it looks like everybody understand what this algorithm works, right? So I hope you can continue with the rest of the questions. Yeah. How do you do this in an online test? Yeah, so that's one of the things that I'm still I'm still trying to think how you do it in the test, and what is the best way to produce this. I guess the easiest way is that I don't ask this question in the test. Yeah, or maybe I just give a multiple choice and then I already draw something, and you have to select which graph is incorrect, and or maybe you have to fill in the missing information, for example, something like this, right? Yeah, I have to figure out the easy way for you to answer this question. Of course, I cannot ask you to draw. There's a way to draw a graph. I think there's some software packages to do that, but I think it will be too much, right, to ask you to do so. Yeah, so if I have to set in a real test, then it's it will be set suitably. Okay. Now that's question 9. I think question 9, 10 is very similar. So yeah, I think we still have 15. Hang on, we haven't finished all the questions. I think we still have to find out the confidence of the rule, right? Okay, so let's go back to that part of the question. So sharing. We haven't done the rules yet. All right, I think we still have the. All right, so we have the 2 rules, A2F and AE2F. Okay, so I'll give you 5 minutes to work it out, and you tell me the confidence of these 2 rules. Um, 50%. Okay. Someone say the AF. Okay, AF. Yeah. Yeah. I think Kevin's answer is more correct. I think it's 66% or 2/3. Sounds more like it. Yeah. Oh, no problem. Yeah. Question 10 for a different question. All right. So the answer to the first rule, the confidence is 2/3 or 60%. All right. What about AE2F? Okay, yep, the confidence score is 1 or 100%, which means that every time a customer buys A and E, he or she will always buy F, right? So you can see that that therefore the confidence is 100% or 1. Okay, so that's the answer to that that part of the questions. I think in the let me check the previous test. I also have another similar question on this, but I think it's just the inverse way. So what I would like to, all right, what I would like to yeah, correct. Craig is asking if the minimum support have any impact on the answer. The answer to that is yes. Everything depends. The confidence is depend actually on the minimum support. So it might affect the hang on, the let me sorry, that's the minimum support value. Oh, okay. Sorry, Greg. We're not talking really about the what to call it, frequent item set for now, right? So I think it doesn't have any impact on the answer at all. It will have the impact only when we consider association rules, because association rules only consider item sets that are frequent. Okay, so yeah, so yeah, that's a good question. Yeah. Candidate item sets. Sorry, Eric, I'm not sure. Oh, there's a candidate item set. Remember, the candidate item sets, basically, yeah, potential item sets, yeah, in the a priori algorithm, which we showed before, right? So remember, when we go from level 1 to level 2, in that example, right, every possible enumerations of items with two item set with two items, right? They are candidate. So candidate is before we actually do the counting, right? But as soon as we finish the counting, then yeah, things that are below the threshold, then they are infrequent, and things that are above the threshold, then they are frequent. Put it that way, yeah. Okay. Now, all right. So one way that I could ask you is to calculate the confidence of the rules, right? But I could pose this another way, which maybe we can do it now if you want. So typically, right, in what we have done is that we calculate the confidence of the some rule like A to F, for example, right? Okay. Now, my question to you here is, of course, yeah, IE to have already calculated, so maybe that's not a great one, but let's just say, let me look at this answer here, and let me just say, okay, so A, B, C, A, B, B, okay. All right, so can you please work out something to, all right, so suppose X, right? So I have a question for you now, and the question is phi X that now X could be an item set, right? Or is an item set actually, but it could be an item set consisting of only one item, or two items, or three items, right? So my question is, can you find such X that give you the maximum confidence, which means that in a typical marketing application, you want to know, for example, you want to promote the sales of item E, for example, right? So what you can do is that you can look at all item set X that if the customer have already purchased item set X, then he or she will also likely to purchase E. And suppose that E is basically much more expensive, right? But you want to increase the sale, so you want to put some discount on X. So when the customer buy X and then also buy E, so you may lose a bit of profit by discounting X, but you have you get the sale for E, right? So overall, you can I guess you can maximize or increase your profit. All right, so I have a couple of answers there. Okay, how did you find out this is F? Eric, Yuri, and Peter, how do you find it now? By eye? not a good answer. Okay, you have to prove it. You have to prove whether F is a better one, and nothing else better than F. If you do that. Yes, that's kind of, yeah. So that's one wood sort of observation combination of E and F. Yeah, that's why I pick E. All right. Is there anything else? Yeah, I think Eric, you are heading the right way. Yeah, you find sub of A, B, C, D, E, F. But remember, right? But remember, how can I put this way? Why do you restrict yourself to only one item set? Oh yeah, so you have to look at the EA, EB, CEF as well. Okay, so what you want to do is you need to find out the all right, so whatever you want to call it. So we have a the confidence, right, of X to, did I say to E, right, is equal to the sub of X, right, and E, right, divided by the sub of X. Right? Are we right? Yeah. Okay. So what you could do then is that of course this is not a easy function to maximize. So you have to find out the combination of something and E, right? So which means that you can find out that, and you have to divide it by the support of that one. So obviously you want to find something that when combined with E give you a large value, and then the support of X itself is as small as possible, right? So yeah, you have to do a lot of combinations, yeah, and compare them all, right? Because this is not something linear, I would say, right? So you have to find all possibilities and try to figure it out which one probably give you the best one. Yeah, but what I can specify in the question is that I will require X to be frequent item set, so that make it easier, right? Reduce the search space, so you can make use of the yeah, exactly. So so first of all, right, X should be frequent because from the statistical point of view, the supermarket would only be interested in items or item set that people usually purchase, right? Not just like any other item set, because some might be very rarely purchased by customer, but they may end up having a large confidence, right? So which is not really interesting from a supermarket's perspective. So X needs to be frequent as well. And if X is frequent, then the list might be less, less than as if X is free. All right, but at least you get an idea, right? If you have to maximize that confidence score, then yeah, how can you do how can you solve the question? Anyway, we only solve for the case of the support equal to 2. I hope you can do the same thing for support equal to 3 and 4. And also question 10 is also very similar. I just give you another chance to practice this kind of question, because I will ask the question in the test for sure. Yeah, is there other question before we close the workshop today? Okay, can you explain the format of the test? So the format of the test, as far as I can see at the moment, is very similar to what you see on Blackboard. I think on Blackboard there must be a mock test, right? If I'm not, let me double check. I thought I have a mock test on Blackboard. Do I? Okay, yeah. So, I will just use the same question in the mock test. Not the same question, but same type of question, right? Except for, as I said before, questions that are about recall, describe, concepts that are typically used in a closed book assessment or in-class test, for example. Then I won't use those questions. Oh yeah, so on Blackboard you should see something called mock test, so you can have a look at that and understand. Is the test is after tuition free week? Oh, very good point. Yeah, bring my attention to the unit outline. So if you open the unit outline, which I'm showing now, to make sure that you are clear, outline. I just pick the postgraduate one. Yes, the answer is yes. It will be after the tuition free week, which is next week. So let me double check. Yeah, so we are now in week 4, association pattern mining, right? And next week you have a full week to revise the material, to practice, and so on, right? I'm actually still reading the IRIS thing, and I will. What I might do is that I might just I guess convert the PDF to Blackboard test, right? And then I will also have the IRIS one for you to test, right? So if you have a webcam, you have a student ID, it's a good time to test if IRIS is working for you. I'm sure that there are people in the class who have used IRIS before, right? Does any one of you want to elaborate on your experience and see common issues that people face? All right. How was your experience? Is it something that you want to share with the class, like? Because I haven't. Okay. Yeah.
Can you hear me?
Yeah. Very, very clear.
Yeah, I used it today for one of the classes. Basically, it just records your, it obviously records your webcam and just records your screen, but it's just in the background. It doesn't really affect it in any way. Okay, so how is it likely to enroll your ID, like show your IDs and screen? Does it work all the time, or? So basically what you have to do is when you first start the test, it will ask you for your name, your ID, and then it will ask you to put a photo or like your student ID up to the screen. So just make sure you have it on you. So it asks you to put your ID up to the screen so you can clearly see it. And then it basically, you click next and it just takes a photo of it. And then once you're done with that, then you start the test. Pretty much. All right. Yeah. Okay. That sounds easy enough. So did you have a real test today or just a practice? No, I did a real test. All right. And are you allowed to look down? Yeah. So basically, at least what they did with the test today, because it's like a maths test, I guess. So they asked you that before you do any working out on your piece of paper, you lift up the piece of paper to the camera so the camera can see what it looks like beforehand. And then you lift it up after you're done with the working out so that you can see it after. At least that was the rule with this one. So I don't know if that's like consistent or... Okay. That's interesting because I've been asked by
at least a student and say, how can I look down, right? And I didn't know the answer. So I think that's your experience is great. So hopefully I can tell the student that you have to show, right, your the piece of paper that you are looking at, right, before and after.
Yeah, and it is, yeah, even though it's open book, basically what it does, Ben, is it records your screen, so you can see all the tabs you have open. So if you, let's say you have like lecture notes or whatever there, then it's got then obviously it will show that you're only looking at them and you're not actually getting it.
Okay. Yeah.
It records both of your monitors if you have 2 monitors, I believe. But in terms of like if you had a separate computer, I mean, obviously you can find a way to cheat in any situation if you try hard enough.
Yeah. Okay. Yeah. So let me make a very clear rule here is that you are allowed to have access to your books and notes and so on, but I would not allow you to access the internet for other reason than accessing Blackboard, accessing the test, or sending me an email, right? I make the rule very clear because I don't want people to go on Discord, go on other social channel to chat and to share the solutions to the answer. So that rule is very clear. No internet access, right? Of course, if you try to cheat the system by having another computer, have another iPad, you go and do it yourself, but that's not allowed, right? I make the rule very clear. I was hoping to have the face-to-face, but since we cannot have that, so the Blackboard test is a way, but I would expect that you respect the conditions of the test. Okay, can you give us a list of what we are allowed to have? Yeah, so maybe it is better that you ask on discussion board, and I can formally describe it, because I tend to forget the questions after the workshop. So it is better for students who are not here today because we have only half the number of students here. So it's better that I say it formally on discussion board. Yeah, for the sake of being consistent. Yeah. Yeah, but the whole idea is any printed materials or handwritten materials, yeah, they are all allowed, right? I'm still checking whether if you have other materials, but I do not want to have electronic materials at the moment. The reason for that is that as soon as I have something electronic, people tend to copy and paste straight away. That's what I don't want, right? I want people to present their own work, because if I have something that, there's some sort of sharing, then a textbook, I suppose that yeah, you can refer to it, right? But it's something that I have to decide, because if I ask, see, this is the problem, right? With FCDS, I noticed people did copy words from lecture slides and textbooks, and then they just copy, and I mean, not everyone, but I know that some of the students tend to copy text from textbook, which then I have to go through all these academic integrity and so on. So preventive is better. You'll be able to see on the screen if they copy and paste through, though. Yeah. Yeah, I mean, in theory that I could, but I do not really have a, I guess, trust or confidence in how well Iris can perform, because this is the first time I have to watch the footage, and I have to figure out, how often that Iris capture abnormal behavior and not. So I'd rather to have some preventive measures rather than having something that I have to spend a lot of time checking people. Oh yeah, so I designed the test to be 1 hour, but yeah, but I probably make it 90 minutes. So yeah, fair enough, because you know you have you have to upload and not upload, download. I think it's just the typing, right? Yeah, but I will increase. Yeah. What do you like to see? What do you in the notebook and upload? No, upload is not allowed this time. It has to be Blackboard test. The reality is that I may have different version of a question so that every one of you would see a different test, not the same test, like the FCDS, but in the first test, not the exam. Sorry, not the final assessment. It will be more likely the first FCDS test. Yeah, see, it's funny though, right? In the first FCDS test, right, that you did, when we had only Blackboard test, and I didn't have any problems with the first test at all, even though it was the first time, right? I think there was only 1 or 2 students who had internet dropout, but then I can manually fix that problem, right? Out of more than 500 students, there was only 1 or 2 students problem, right? Now, in the final assessment, FCDS, right, there was something like 20 plus problems with uploading and downloading the files, right? One of the problem is student was working on the Word document, but didn't click the save button and then end up submitting an empty exam. Some people submit different things, right? A lot of issues and some other and the most I guess severe problem is some people end up cheating, right? Collusion, cheating, a lot of issues, and I spend so much time on reporting and academic integrities, and things are still going on. So I don't want to spend time, going through all the reporting again. So I would like to have something that works better, in my opinion, and something that works better is basically would rather manually intervene the test and then allow people to have more time if they had some difficult technical difficulty, rather than having a test that is easily exploited. Okay. Yeah, everything up to today. Yeah, everything that we studied from beginning. Okay, so the test is during the lecture hours on Wednesday. So that week starts from September, right? But Wednesday is the 9th of September, right? As far as I can tell. Is it the 9th? Yeah, so the 9th of September. Okay, so 9th of September. So 9th of September. Okay, that makes it clear, everybody. Now, I think 1 or 2 students in the class say that they are working a bit late, so maybe I start the test at 6:30. Oh no, we don't have the workshop on the 9th. That's the time when we do the test. All right. Any further question? Okay. Yeah. Any further question on discussion board? All right. Okay. So thank you everybody for attending today. Yep. I will hopefully see you after the tuition-free week when we have the test.